We have two more application questions to work on in section 8.2. Question 6, Olympic Sports purchased 380 river rafts for $7,600. If they sold 158 of the rafts at $45 each, 74 rafts at $35 each, 56 rafts at $30 each, and the remaining rafts at $25 each. We have to find the total amount received for the rafts, the markup as a percent of selling price, and the markup as a percent of cost. This is a lot of information, so let's take it one small bit at a time. In that first sentence, it says that there are 380 rafts and the store purchased them for $7,600. If the store cost is $7,600, that means its cost is $7,600. When we're using our percent cost, percent markup, and percent selling price, that cost is the $7,600. Okay. Now, we want to find out the total amount they received for all of the rafts. Well, they kind of detail it out. So let me put here 158 of the rafts are at $45 each. So 158 times $45 each gives me a total of $7,110 for those 158 rafts. 74 rafts at $35 each. And then when we multiply that, I get $2,590 for those 74 rafts. 56 rafts at $30 each. And that gives a total of $1,680 for those rafts. And then it says the remaining rafts are $25 each. So I've got to figure out how many rafts fit here. Well, to know how many rafts fit here, I know there's 380 rafts total. So let's add how many rafts we've already calculated. And we need 380 total. So 158 plus 74 plus 56, if we add that up, 18, I get 288 rafts so far. So 300 minus 288 rafts, going back, we have 380 rafts. So 380 rafts minus 288 rafts. And I end up with 92 rafts left in this category. So 92 rafts times $25 each, and that gives us a total of $2,300. So we're going to total all of the money that came from all the different raft prices. And when I add it all up, I get $13,680. And this is the total selling price of all the rafts. That's actually part A, the total amount received from all the rafts. Let me even highlight it with a different color here. So we answered part A, and I'm going to put that also in our table. The total selling price was $13,680. That helps us work backwards to find this section, the markup. We can take our cost plus our markup is the selling price. We know the cost was $7,600, and we now know the selling price was $13,680. We can use our subtraction to find the markup, and I found the markup to be $6,080. And that's part B, the total markup. So we've answered part A, and we've answered part B, the total markup. Part C and part D, part C is the markup as a percent of selling price, and part D is the markup as a percent of cost. For each of those, I'm going to create a fraction. Part C, markup over, and for Part C, it's markup over selling price. The markup we said was $6,080, and the selling price was $13,680. As a decimal, I get 0.444, lots of fours, which as a percent, that would be 44.4% if you're rounding to one decimal place. For Part D, let me go ahead and label that one's Part C. For Part D, we're going to work with a fraction, but now it's going to be markup on top of cost. And our markup is still $6,080. Our cost was the $7,600 that they told us from the very beginning. And with our division, I get 0.8. And changing that into a percent would be 80%. This one was markup on selling price. For Part C, 44.4%, and then this last one, Part D, is markup on cost. So now we've answered all four parts of the question. Let's take a look at question 7. Something unique about question 7 is that we're looking at having some of our items spoil and they can't be sold. Okay. We have a store and they know that 10% of the bananas will spoil and have to be thrown out. So the manager buys 500 pounds of bananas at 56 cents a pound and wants a markup of 45% on selling price. We need to find the selling price per pound of bananas that can sell. Really what we need to find is we need to find the total selling price of all the bananas, because the store hopes to sell them all. And then we're going to divide by just the number of bananas, and in this case, the pounds of bananas that can sell. So let's start with that numerator, total selling price. For total selling price, I'm going to use our cost plus markup equals selling price. And over here, we put our dollar signs. And on the left, we use our percent signs. So very familiar to a lot of the questions we've already worked with. Okay. I'm going to start with finding the cost of all the bananas to the store. Well, the cost is 500 pounds of bananas were purchased, and they were purchased for 56 cents a pound. Multiplying, I'll take my 500 times the 56 cents, and I get that the cost was $280. I'm going to rewrite that to make sure that my number is easier to read. In my chart, let me put $280 for cost. Something else I was told is that the markup is 45% on selling price. So that tells me two things. 45% goes in the percent section for markup, and also because the percentage is on selling price, 100 goes in the percent section for selling price. And that helps us work backwards. And we can say that 100% minus the 45% would be the missing 55% in the cost section. And now I'm going to work to fill in these other two spaces. Remember, our goal is this total selling price. We need that number. I'm going to use this completed row to make a sentence. The cost is 55% of, and remember, it's of the selling price, the percentages. So that becomes my equation. The cost amount was $280 is equal to, I'll change that 55% into a decimal, and I'll use S for selling price. Don't forget the of is multiplication. Solving, I get a total selling price of $509 and 10, or excuse me, if I'm rounding, 9 cents. Let me put that in my chart. Okay. We could find the markup amount, but it's really not needed for this question. We needed the total selling price of all the bananas, and we have that, $509.09. So for this market to be able to make the money they need to have all of their expenses paid, they need to sell the bananas for a total of $509.09. The last thing we want to do is find out how many bananas can sell. Well, not all the bananas can sell. Remember, they said that 10% spoil. 10% of the 500 pounds spoil. So let's find out how much spoils. 10% is 0.10 as a decimal, 500 pounds of bananas, and 10% of 500 pounds is a multiplication, and we get 50 bananas, or excuse me, 50 pounds of bananas spoil. Well, if 50 pounds spoil, 500 pounds minus the 50 pounds that spoil leaves 450 pounds of bananas that are good. So we're going to take our total selling price and divide by the 450 pounds of bananas that we can sell. And I'm going to get $509.09 divided by 450 pounds. I get $1.13 when I'm rounding per pound of bananas. So each pound of bananas is $1.13. Let me go back over just to refresh the different stages that we went through. Part A, we first found the cost of all the bananas and put that in our chart. We used that chart to find that total selling price. We needed that total selling price, and that went in the numerator of our fraction. The next thing we did is we found how many bananas were good to sell, and we put that in the denominator of our fraction. And we took the total selling price divided by the number of good bananas that could sell, in this case pounds of bananas, and we found the price per pound. And that's the end of section 8.2.